All right, let's talk about a new tool from Hugging Face called Dagger. And honestly, it's designed to solve a problem that I'm sure every AI developer has run into. That massive headache you get when you're trying to chain a bunch of different models together and just pray that it all works. Well, Dagger might just be the solution we've been waiting for. So let's get into it.
So let me ask you this. Have you ever tried to string a few AI models together to create a single, bigger workflow? Something cool like you take a photo, one model rips out the background, another one enhances it, and a final one turns it into a 3D asset? If you've ever tried anything like that, you already know the pain I'm talking about.
Yep. It is an absolute debugging nightmare, isn't it? You spend all this time building this really elegant, intricate chain of models, and then one little thing goes wrong, like way down the middle of the process, and the whole thing just collapses. It's like a house of cards.
And that right there, that's what we're going to call the AI workflow nightmare. It's something pretty much everyone in the field has experienced, and it comes down to some really specific, really frustrating issues with the old way of doing things.
I mean, this quote from the team behind Dagger just nails it. You've got, say, a 10-step workflow, and step 5 fails. What's your only option, really? You have to go all the way back to the beginning and rerun everything just to see what happened. It's a massive waste of time, a massive waste of compute, just so inefficient.
Okay, so let's break this down. The old way versus the Dagger way. With the old way, you're dealing with these brittle scripts that are just a pain to maintain. And when something breaks, you got to rerun the entire pipeline. It's almost impossible to see what's happening to your data between steps. And sure, you could use a big GUI editor, but those can be so clunky. Now look at the Dagger way. Your entire workflow is just Python code, so you can version control it, you can rerun and inspect any individual step. You can literally see every input and output visually. It's a code-first approach that auto-generates the canvas for you. You're not forced to work inside a clunky UI.
So how in the world does it pull this off? Well, let's properly introduce the star of the show, Dagger. The whole idea is simple but powerful. It's where your code meets a canvas.
So what is Dagger? Well, at its core, it's a Python library. It's open source. And the workflow is this. You write your multi-step AI pipeline in plain old Python, connecting models, custom functions, whatever. And Dagger automatically, magically, generates a visual interactive canvas right from your code. And that's the key thing to remember. Your code is always the single source of truth.
It's really the best of both worlds, isn't it? You get all the power and flexibility that comes with writing code. Like using Git for version control, but you also get the amazing clarity of a visual canvas when it's time to debug and see what's actually going on. You don't have to choose anymore.
So let's look at the key features that make this all happen. First, it visualizes your code automatically. You write Python, you get a diagram. Simple as that. The second one, and this is the real game changer for me, is that you can inspect and rerun any step. You can literally go to step 3, tweak an input, and just run that one piece again, not the whole pipeline. It also has incredible integration with Gradio and Hugging Face spaces, which just makes connecting things a breeze. And finally, it has state persistence. So if you stop working, it saves everything, and you can pick up right where you left off.
Okay, so that's the big picture view. But how does it actually work? Let's get a little more technical and look under the hood. The whole system is built on one core idea: nodes.
Basically, every single step in your Dagger pipeline is what's called a node. You can think of them like Lego bricks for building your AI app. And the cool part is, there are 3 main types of these bricks you can use, which gives you a ton of flexibility. Let's check them out.
First up, you've got the Gradio node. This thing is awesome. It's basically your gateway to the entire Hugging Face ecosystem. You can point it to any Gradio app running on a public or private space, and boom, that app is now a node in your workflow. It can even download the space and run it locally for you. Super powerful. All right, next up is the F node, which is short for function node. This is for all that little custom stuff you need to do. Maybe you need to resize an image before you pass it to the next model, or clean up some text, or do some kind of calculation. You just write a normal Python function, wrap it in an F node, and it slots right into your workflow. Total flexibility. And the third type is the inference node. This one is all about speed and optimization. When you just need to call a model and you need it to be fast, without all the extra stuff from a full Gradio app, this is what you use. It connects you directly to Hugging Face's inference providers for the best possible performance. Okay, so theory is one thing, but let's see this in action. We're going to look at a really cool example from the Dagger docs, a full pipeline that takes a regular 2D image and turns it into a 3D asset. This is where you see how all those nodes come together. So here's the game plan. It's a 4-step process. Step 1, we take an image and remove the background. Step 2, we'll downscale that image just to make things run a bit faster. Step 3, we'll use a model to enhance the image, give it more of a 3D-friendly style. And finally, Step 4, generate the actual 3D asset. 4 clear steps, 4 perfect nodes.
Okay, let's look at the code. For step 1, removing the background, we use a Gradio node. We just pointed at an app that already does this. Easy. For step 2, downscaling the image, that's just a simple function, so it's a perfect fit for an FN node. You can already see how you're mixing and matching the right tool for each part of the job.
Now for the really heavy lifting. Step 3 is enhancing the image with a powerful model. For that, we want speed, so we'll use an inference node to call the model directly. And then for the final step, creating the 3D asset itself, there's a great tool for that on Spaces, so we'll use another Gradio node. And there you have it. In just 4 steps, we've used all 3 types of nodes to build a pretty sophisticated pipeline.
And you know what the best part is? After you've defined all those nodes and how they're connected, how do you run it? It's just one line of code, graph.launch. That's it. No messing with servers or UI configs, you just launch it.
And this is where the magic happens. That single command pops open this amazing interactive canvas. You can see your 4 nodes all wired up. You can drop your image into the first one, hit run, and literally watch the data flow from step to step. And if the final 3D model looks a little off, no problem. You just go back to the enhancer node, tweak the prompt, and rerun only that one step. For debugging and just playing around, this is a total game changer. Okay, so let's zoom out for a second and think about the big picture. Why does this matter so much? Why is an approach like this potentially going to change everything for people building with AI?
Well, here are the main takeaways for me. First, and this is huge, you can stop rerunning everything. Your debugging becomes so much faster and more precise. Second, your code is the actual source of truth, which means you get all the benefits of things like version control and easier collaboration. It really helps bridge that messy gap between just experimenting and building something production-ready. And finally, it makes prototyping super fast. You can just swap out one model for another by changing one line of code to see what works best.
Now, quick heads up, Dagger is currently in beta, so APIs and things might still change as it evolves. But even at this early stage, the idea behind it, this code first, but with a visual safety net approach, it really feels like it's pointing to a much, much smarter way to build these complex AI systems. And that kind of leaves us with a big question to chew on, right? Is the future of building complex AI not just about who has the biggest, most powerful model, but about who has the smartest, most elegant ways to connect them all together? It really makes you think.